Have you ever pondered the intricacies of quantum computing only to find yourself lost in a labyrinth of complex concepts? Well, you're not alone. Quantum computing, with its mind-boggling principles and peculiarities, can seem like a daunting field. But it's also a field brimming with immense potential. Quantum computing operates on the principles of quantum mechanics, a branch of physics that deals with the microscopic world. It's a world where particles can exist in multiple states at once and influence each other from afar, a phenomenon Albert Einstein famously dubbed spooky action at a distance. Yes, it's a tad strange, and yes, it can be challenging to wrap your head around these concepts. But that's where the beauty lies. So fear not. We're here to guide you through this mesmerizing maze of quantum mechanics and computing. With each step, we'll unravel the complexities, making the quantum world a little less daunting and a lot more fascinating. Prepare to dive into the quantum realm and unravel the mysteries of quantum computing. Opening. To truly appreciate the power of quantum computing, we need to understand its predecessor, classical computing. Picture a world where every decision is a straightforward yes or no, black or white, 0 or 1. That's the realm of classical computing. At the heart of every classical computer are billions of tiny switches called transistors. These transistors work in a binary fashion, either allowing electricity to flow, representing a 1, or blocking it, representing a 0. This binary system, a symphony of on and off switches, forms the basis of all classical computing, from your smartphone to the most powerful supercomputers. Now let's journey into the world of quantum computing, where things get a little peculiar. Instead of binary bits, quantum computing uses quantum bits or qubits. Unlike classical bits that are definitively 0 or 1, qubits can be both at the same time, thanks to a quantum quirk known as superposition. Imagine being able to say yes and no simultaneously, or being both here and there at the same time. That's the essence of a qubit. But wait, there's more. Quantum computing also leverages a phenomenon called entanglement, where the state of one qubit can instantaneously affect the state of another, no matter the distance between them. This spooky action at a distance, as Einstein called it, allows quantum computers to process vast amounts of data simultaneously. The combination of superposition and entanglement gives quantum computers the potential to solve complex problems that would take classical computers millions of years. They can handle vast amounts of information, perform multiple calculations at once, and even find the optimal solution among countless possibilities. In essence, while classical computing speaks in absolutes of zeros and ones, quantum computing thrives in probabilities. It's like the difference between reading a book one word at a time, and reading every possible version of the book all at once. Closing. In essence, while classical computing speaks in absolutes of zeros and ones, quantum computing thrives in probabilities. The heart of quantum computing lies in a seemingly simple yet incredibly complex concept, the qubit. Now you might be wondering, what exactly is a qubit? Well, in the world of classical computing we have bits. These bits are binary, they can be either a 0 or a 1. But here's where quantum computing shakes things up. In quantum computing, we have qubits, quantum bits. These qubits, unlike classical bits, can be in a state of 0, 1, or both at the same time. This is thanks to a property called superposition. Just imagine, if you will, a coin spinning in the air. While it's spinning, you can't definitively say it's heads or tails. It's in a state of both. That's a qubit in superposition. But the moment you catch it, the coin or qubit collapses to one state, heads or tails, 0 or 1. But there's more. Qubits can also be entangled, another unique quantum property. Picture a pair of dice. In an entangled state, no matter how far apart these dice are, if one lands on 6, the other will too, instantly. This instant connection, regardless of distance, allows quantum computers to process enormous amounts of data simultaneously, far surpassing the capabilities of classical computers. Now let's put it all together. These qubits, with their superposition and entanglement, allow a quantum computer to process multiple possibilities at once, rather than sequentially as in classical computing. This means quantum computers can solve complex problems faster and handle operations that would be beyond the reach of classical computers. Despite the complexity of these concepts, they are the foundation of quantum computing. And it's this very complexity that gives quantum computers their incredible power and potential. The qubit, with its ability to exist in multiple states at once, propels quantum computing into a realm of possibilities beyond the reach of classical computing. Quantum computing isn't just a theoretical exercise, it's a tool with real-world applications that can change our lives. Let's delve into some of these applications. First, let's talk about cryptography. Today, a lot of our online security relies on the difficulty of factoring large numbers into primes. But Shor's algorithm, when run on a sufficiently powerful quantum computer, could crack this problem wide open. This has profound implications for security and privacy in our digital age. Next, consider drug discovery. Simulating molecules is an incredibly complex task due to the quantum nature of particles. However, quantum computers operate using the same quantum principles, which could allow them to model complex molecules accurately. This could greatly accelerate the discovery of new drugs, potentially saving countless lives. Then there's weather forecasting. Current models are limited by their computational capacity. Quantum computers, with their ability to process enormous amounts of data simultaneously, could provide more precise and timely predictions. This could help us better prepare for natural disasters, potentially saving lives and billions of dollars. Quantum computing could also revolutionize logistics and supply chains. Companies like UPS and FedEx deal with an astronomical number of package routes. Finding the most efficient delivery route is a problem of colossal complexity. Quantum computers could find optimal solutions faster than ever before, saving time, fuel, and reducing carbon emissions. These are just a few examples. Quantum computing could also have significant impacts on fields like artificial intelligence, financial modeling, and even climate modeling. The potential of quantum computing is immense, and we're only just beginning to scratch the surface. From medicine to meteorology, from cryptography to commerce, quantum computing stands to revolutionize our world in ways we can barely imagine. Remember, these aren't distant theoretical benefits. Quantum computers are already being used in research and development. Companies and governments are investing billions into quantum computing research. This isn't science fiction, it's science fact. Quantum computing holds the key to unlocking solutions to some of the world's most complex problems. Quantum computing is not a distant dream, it's a reality unfolding before our eyes. As we navigate through the 21st century, the ebb and flow of technology has washed us up on the shores of a new era, the age of quantum computing. This isn't a mere concept confined to the realms of science fiction, but a tangible reality that's being shaped and reshaped by some of the brightest minds in the world. Today, we find ourselves anchored in the midst of a fascinating journey. We're witnessing the growth of a technology that's as enigmatic as it is promising. Quantum computing, as we know, is still in its infancy. But let's not underestimate the strides we've made. Major tech giants and research institutions are pouring resources into quantum research, pushing the boundaries of what's possible, and paving the way for a future that was once just a figment of our collective imagination. However, the path to achieving full-scale practical quantum computing isn't without its hurdles. One of the major challenges we face is the issue of quantum error correction. This means ensuring that the delicate state of qubits, the building blocks of quantum computers, are not easily disturbed by their surroundings, a phenomenon known as decoherence. But just as every challenge presents an opportunity, this too has sparked a surge of innovative solutions. Scientists around the globe are racing against the clock, exploring novel techniques to sustain the fragile quantum state. And every day brings us a step closer to a breakthrough. Moreover, the potential of quantum computing is vast and virtually untapped. It's anticipated to revolutionize fields ranging from cryptography to climate modeling, drug discovery to artificial intelligence, and so much more. In essence, quantum computing is a journey into the unknown. It's a thrilling adventure filled with unexpected twists and turns, challenging problems, and breathtaking possibilities. As we stand on the brink of a quantum revolution, the future of computing promises to be as exciting as it is unpredictable. Quantum computing can seem like a maze, but hopefully, we've helped illuminate the path. Let's take a moment to revisit the key points we've discussed. Unlike classical computing, which uses bits that are either a 0 or a 1, quantum computing employs qubits, which can be both simultaneously. This concept, known as superposition, allows quantum computers to process an astronomical amount of data at once. We've also explored the potential applications of quantum computing. From revolutionizing the fields of medicine and logistics to breaking new ground in cryptography, the possibilities are staggering. But let's not forget the challenges. Quantum computing is still in its infancy, and numerous technical hurdles stand in the way of mainstream adoption. However, the future is bright. As we continue to peel back the layers of complexity, we uncover more and more about this fascinating technology. By peeling back the layers of complexity, we can begin to comprehend the immense potential held within the quantum world.